we are going to review factoring. So hopefully this is something that you remember how to do. So number 1 asks solve by factoring. I recommend that you factor using the box that we talked about last year. For some of the easier ones, you don't really need to, but for the more difficult ones, it's certainly the easiest way to do that. So I'm going to draw a box, and in order to factor, the quadratic has to equal 0. And then you take the first term, and you stick it in the first square in the box, and you take the last term, and you stick it in the last spot of the box, and then you multiply those two terms together. So x squared times 6 is 6x squared. Now if we look at the signs of the original equation, this is positive. I'm looking for two numbers that multiply to be positive 6. If two numbers multiply to be positive 6, what do I know about the original two numbers? They're the same sign. They're either both positive or they're both negative. How do we tell? We look at the middle sign. So we're looking for two numbers that multiply to be positive 6 and add to be negative 5. So if we look at the factors of 6, our options are 1 times 6, so 1x times 6x, or 2x times 3x. Does one of those create a negative 5? So negative 2 and negative 3, what about 1 and negative 6? Right, they both have to be negative, so if both of those are negative, it doesn't work. If both of those are negative, it does work. So I have negative 2x and negative 3x. Do you remember what you do from here? What does the top row share? X. Now, don't factor anything out. Let me say that a different way. When you get to this point, look in the top row and see what they share. From then on, you need to look at the multiplications. If you always factor out the common term, there's a chance you're going to miss a sign later on. So what we ask is, what times x is x squared? So x goes up here. What times x is negative 2x? Negative 2. And what times this x is negative 3x? Negative 3. And we can check, is negative 3 times negative 2 equal to positive 6? Yes. So my two factors are x minus 2 and x minus 3. But it wants to know what the roots are. How do I find the roots? Set them equal to 0 and solve by adding 2, so x equals 2, and adding 3, so x equals 2 and 3. Okay? We're going to do all of that first set. But there are a couple that I want to talk about before, and I don't care if you work these out of order. So let's look at number 5. How are we going to solve number 5? It's got to be equal to 0. Do I want to move everything to the right or to the left? Why the left? We want the x squared to be positive. Good. So x squared minus x, plus x minus 12. Okay? So I'll draw the box. X squared and negative 12. Multiply those two together. Negative 12x squared. Are there factors of negative 12x squared that add to be 1? 4 and negative 3. So 4x, negative 3x. So the top row shares an x. This would be x. This would be plus 4. And this would be minus 3. And I double check, is negative 3 times positive 4 negative 12? Yes. So my factors being x plus 4 and x minus 3, what are my roots? Negative 4 and positive 3. Okay? Everybody gets that? Number 6 is a little bit harder. So for number 6, do I want to move everything to the left or to the right? To the right. So 2x squared minus 11x plus 12. Ideally, I would like to divide out a 2. Can I? No, because 11 is prime. If I could divide out a 2, what do I do with it? I'd put it outside, and how is it going to affect my answer? So if I had 2 times some quadratic that I factored like this, let's say x minus 4 and x plus 10, what effect does 2 have on the answer? Well, the goal is to find out what x equals. So in this case, x would be 4 and negative 10. Putting that 2 back in isn't going to change these. So if you're finding the roots, this 2 doesn't matter. What does dividing an equation by 2 do to the graph? It makes a steep graph wider, but it doesn't change the roots. So if I had a quadratic that looked like this, and these are my 2 roots, dividing it by 2 is going to make the graph a lot wider, and it will change every point except the roots. So 2 is a factor, but it's a factor that doesn't contain an x, and only the x's tell us where the roots are. So when you're finding roots, you can just divide by the number and then forget it was ever there. Now, if you're finding maximums or minimums, or if you're looking for, what does x equal at negative 5, you have to use the original equation. But if all you care about are the roots, you can go ahead and divide it, and it won't change anything. Okay. So we have the box. 2x squared plus 12. Now this one has a leading coefficient. A lot of you are good enough you can factor without the box. But if there's a leading coefficient, I highly recommend you use the box. In fact, that's what I do. The way I learned it almost 20 years ago was way harder than the way that we do it now. So we take 2x squared and we multiply it by 12 and we get 24x squared. And now we're using the factors of 24 to create negative 11. What are they? 8 and 3, and they're both negative. Good. So negative 3x and negative 8x. What does the top row share? An x. X times what is 2x squared? 2x. X times what is negative 3x? Negative 3. And 2x times what is negative 8x? Negative 4, and we double check, is negative 4 times negative 3, 12. So we probably did it right. So my factors are x minus 4 and 2x minus 3. This root is easy. It's just 4. What is the second root? So we need to set it equal to 0, add 3, and divide 2, 3/2. Is it all coming back to you now? Okay. Let me look through there, see if there's any others we need to do. How are you going to solve number 11? So number 11, 8y equals 16y. So 8y squared minus 16y equals 0. Oh, you can take the 8 out. It doesn't matter. Y squared minus 2y. How do you factor this? I could divide by y, but dividing by y will delete one of my answers, right? So instead of dividing by y, what's that? Is this a difference of perfect squares? No. Is 2y a perfect square? So you're looking at number 15. How would you do 15? X plus 3, x minus 3, and that works because x squared is a perfect squared and 9 is a perfect squared, and there's a subtraction. So you're overlooking a really easy step here. Do these two terms have anything in common? A y. So I pull out a y. What's left? Y minus 2. So now I can set this equal to 0. And I get 0 and set this equal to 0. And I get 2. Which makes sense. Any quadratic that does not have a constant has what as its y-intercept? 0. And if the y-intercept is 0, it must hit the origin, which means that one of the roots is also 0. So anytime you're missing a constant, you can pull out a variable, and that variable will set itself equal to 0. Okay? Yes, you're going to do 1 through 22, evens and odds. How are you going to solve number 18? We can take a 3 out, and then I get t squared minus 16, and now it's a difference of perfect squares. Okay, what about number 22? Divide by 7, and then it's a perfect square again. Okay, that should be a pretty easy set. Good luck.